Hello, everyone, and welcome to the Apalachicola Chattahoochee Flint River Basin Drought Assessment webinar for the month of July. My name's Rachel McGuire, and I'm with the Auburn University Water Resources Center located in Auburn, Alabama. If you're new to the webinar, I just want to make sure everybody knows we will have time for comments, questions, and any discussion at the end after all of our speakers have had their turn. Please use the question box on the GoToMeeting tool panel to type any questions you may have, or you can also use the raise your hand function by pushing the hand icon on that same tool panel. Speakers, please remember to keep yourselves muted until it is your time to speak, in which case remember to unmute yourself. If we have any problems, I can manually unmute for you. Our speakers today will be David Zierden of the Florida Climate Center at Florida State University, where he is the state climatologist. He'll be speaking with us on our current drought status and our seasonal forecasts and outlooks. In for Tom Littlepage, I'll be speaking on his behalf from the Office of Water Resources for the State of Alabama input. We have Paul Ankhorn, a hydrologist with the USGS South Atlantic Water Science Center. He'll speak with us on our current stream flows and groundwater conditions. We also have Troy Ephraim of the Army Corps of Engineers Mobile District speaking on our ACF reservoir conditions. We have Jeff Dober of the NOAA National Weather Service Southeast River Forecast Center giving us our stream flow forecast for the ACF. And then we'll have a special presentation on the Coastal Salinity Index by Kirsten Lackstrom of the Carolinas Integrated Sciences and Assessments, or CISA, at the University of South Carolina. And we will also have Matt Pedowick of the USGS South Atlantic Water Science Center. Just one last reminder, speakers, give me a cue when you're ready for your next slide, and we'll get started with David Zierden.
Okay, yeah, thank you very much, Rachel. Good to join the group again. We're going to begin this webinar like we usually do with what's in the news. If we can go to the news slide, yeah, the main newsmaker over the last several weeks is the active hurricane season in the Atlantic Basin. Right now, we are on pace for a near record activity. I doubt that'll hold up the whole season through, but we're off to a really strong start. We've had the earliest G and H named storms since the satellite record. However, of these storms, Hannah was the first hurricane of the year as it made landfall in South Texas and also brought pretty heavy rain to northern Gulf Coast and even the peninsula of Florida. The main development region in the Atlantic between the Leeward Islands and the Azores is becoming more active now, as it usually does this time of year. We had one storm develop in this main development region, Gonzalo, but it dissipated in the Eastern Caribbean. One other item is, even though we're on a strong pace for the number of storms, the accumulated cyclone energy, or ACE as we call it, is actually around near normal, since most of these storms were weak and short-lived. All right, the next slide. We'll take a look at what's happening now in the tropics, and I apologize, I put this slide together this morning, so it's a little bit dated. This investigation 92L, the National Hurricane Center at 11 o'clock began issuing advisories as a potential tropical cyclone, and the center of the 5-day forecast cone is actually right around southeast Florida. So it's certainly something to watch. I'll take this opportunity to go on a little rant. Whenever I hear the term spaghetti models, it makes me cringe. These numerical weather prediction models are incredibly complex computer programs that rely on a worldwide network of weather observations from the surface, upper air, and satellite to arrive at a forecast. And so they're not forecasting, or they're not simulating pasta. And each of these models comes with its own strengths and weaknesses and biases, and even the best ones sometimes don't handle the current situation correctly. So with all that being said, the experts at the National Hurricane Center uh, know all these ins and outs of each model and account for them and come up with the best possible forecast along with its uncertainty, where internet warriors just showing these spaghetti plots and claiming something really makes me cringe. Uh, but the National Hurricane Center can get even from time to time. This next system, when it's named, will have an incredibly complicated name to pronounce that'll have broadcasters across the nation struggling for nearly a week. Over on the bottom left, the local Hispanic weather broadcaster made a really funny video on how to correctly pronounce it. I'm not even going to try. I'm going to leave it for the rest of us to practice. On the next slide, we'll take a look at the climatological perspective, or actually this is just a review. This is the 2020 Atlantic hurricane season forecast from NOAA. Just a review. It's one of the most active forecasts in the last 8 years, I believe, where they're forecasting a 60% chance of above normal activity and a very little chance of below normal activity. Over on the right, you can see kind of the range of storms they're forecasting: 13 to 19 named storms, 6 to 10 hurricanes, 3 to 6 of which may become major hurricanes in strength. On the next slide, we'll just take a look at the climatological perspective. Here I show a plot of all the historical points of origin and hurricane tracks during the first 10 days of August. And we see that now that main development region in the Atlantic has become more active historically the first week of August. There's also kind of clusters of formation near the Leeward Islands and also in the Gulf of Mexico. So the storms we've seen are kind of following right along with climatology. Over on the right is a plot of sea surface temperatures, and I see a lot of sea surface temperature anomaly maps that indeed show this whole region of the Atlantic, Caribbean, and Gulf of Mexico is warmer than normal. But anomalies don't drive the system. It's the actual temperatures themselves. So early season anomalies might not mean that much because the water is still relatively cold. But as we see now, a broad area of 27 and 28 degrees Celsius sea surface temperatures across basically the whole portion of the active basin. So the ocean is primed for additional hurricane activity. So on the next slide, we'll go ahead and leave the tropics and drill down to drought here in the ACF and the tri-states area. And this is the current US Drought Monitor, which is showing a little more color than our last webinar. We see spots or sporadic places of abnormally dry or D0 across mid-Georgia, southeast Alabama, and even the west coast of Florida has developed. These areas are very splotchy up in Georgia and Alabama, which is typical of the climatology where summertime convective rainfall is much more scattered than during other seasons. On the next slide, we'll take a look. This is a tool that I find very useful during the summer here in the Southeast, especially for identifying quickly developing drought. It's the Lawn and Garden Moisture Index from University of Alabama, Huntsville. And it shows a similar pattern to the Drought Monitor, real dryness developing over in eastern Georgia, southern Georgia, and north central Alabama. Due to recent rains in the past few days, the peninsula of Florida looks much better than it did a week ago. On the next slide, we'll start taking a look at recent rainfall. These are multi-sensor precipitation estimates relying a lot on our NEXRAD radar system. Anyway, over the last 7 days, the accumulations are fairly good where you'd expect them, along the northern Gulf Coast, the panhandle of Florida, the peninsula of Florida, all with 3 to 4, maybe even 5 inches of rainfall in some place in the last week. But as we get into inland Georgia and Alabama, we see that spotty nature of summertime convection. Some areas with adequate rainfall, other areas shaded blue only received a fraction of an inch in the last week and are probably starting to feel some drying effects. On the next slide, we'll take a look a little further back, and this is now accumulations over the last 30 days. And this climatological pattern is still holding true. Plentiful rainfall, over 10 inches in some areas of peninsular Florida and the western Florida panhandle. But again, lesser amounts of only 3 to even 2 inches or so across inland Georgia, inland Alabama, and the majority of the ACF basin. On the next slide, we'll look even further back, and now we're going to look at rainfall deficits and surpluses rather than totals over the last 90 days. And here you see kind of a very similar pattern, mostly above normal rainfall across all of Florida and the lower ACF basin, the Florida panhandle. A mixed bag of near normal, mostly across the rest of Georgia and Alabama and the middle and upper ACF basin. So with that, we'll start looking ahead. We'll begin with the 7-day quantitative precipitation forecast from the National Weather Service. And what it's showing is we're going to be in a fairly persistent pattern of an amplifying trough over the eastern United States, which is going to bring heavy rainfall and a storm track across Tennessee and the Mississippi Valley, and possibly even impinging on the Lake Lanier area, northern Georgia, the headwaters of the ACF basin. But further south in the middle and lower ACF basin, it'll be more typical summertime pattern of just the scattered convective afternoon showers. So on the next slide, we'll start taking a look at the Pacific Ocean and the kind of will it or won't it development of La Nina conditions. Here I show the current sea surface temperature anomalies over the Pacific Ocean, and we see still fairly strong cold anomalies in the eastern Pacific off the coast of South America. But once we get out into the central Pacific, it's much more of a broken pattern, and the anomalies are not nearly as strong. So it's not really a classic La Nina configuration now. Not enough cold water in the central Pacific right now. And on the bottom is our familiar Nino 3.4 index, and we see at some point, even in late June, it returned to close to 0. Now it's back on the cooler side again, but still mostly still less than that -0.5 degree threshold that we need for La Nina conditions. So on the next slide, we'll take a look at what's happening below the surface. And this is an equatorial cross section of sea surface or ocean temperatures, departures from normal or anomalies at depth. And over on the right-hand side, we have 4 panels that begin near the 1st of June, actually on June 2nd, that show a lot of colder water beneath the surface from the central all the way to the eastern Pacific. And this is as a upwelling Kelvin wave made its 2-month journey across the Pacific Ocean. But as we move forward in time going down, we see that Kelvin wave kind of reaches the coast of South America and has just about run its course. And over on the left is the current subsurface ocean temperatures. And you see there's really not a follow-up Kelvin wave or any follow-up support for continued cooler temperatures in the Pacific. So looking at this, I'm a little more guarded about the prediction of La Nina conditions later this summer and in this fall. With that in mind, on the next slide, we'll see the official NOAA forecast. And now they are forecasting a 55% chance of La Nina conditions as we get into the fall season, September, October, and November. because it's more likely than not, we are now under what's known as a La Nina watch, which means conditions could be favorable for continued development. Like I say, I'm still a little more conservative, so we'll keep an eye on it, wait to see. This could be a player in our fall and winter climate patterns. Over on the right is just the different model predictions for that Nino 3.4 area for the sea surface temperature anomalies in Nino 3.4. And you see there's a pretty good spread from some models predicting a return to warmer conditions, others predicting a rather strong La Nina, one real outlier. I'm not even sure which one that is. I do know that NOAA relies heavily on the CFS version 2, and it's been pretty bullish on predicting cold sea surface temperatures. So again, right now we're kind of waiting and see and kind of which way it's going to go. So with all that in mind, we'll go to the next slide, start looking ahead at our the official seasonal outlook from NOAA's Climate Prediction Center. Over on the left is the temperature outlook, where basically the entire United States has a fairly strong probability of above normal temperatures. This goes right in line with recent trends over the last decade or more, and also summertime trends. Kind of more interesting over on the right is the precipitation forecast, where they are still showing increased chance of above normal rainfall for the entire Southeast and the ACF Basin for the next 3 months. So that's still good news as far as keeping us out of drought. On the next slide, we'll wrap up. This is the seasonal drought outlook issued by NOAA's Climate Prediction Center, and seeing as most of the eastern United States is drought-free or only in that D0 or abnormally dry, their outlook is for it to remain relatively drought-free for the next 3-month season. So with that, we'll go ahead and wrap up. Kind of our summary. We've had an active start to the hurricane season in numbers of storms, but accumulated cyclone energy is actually around normal right now. Pockets of abnormally dry are starting to appear in southeast Alabama, central Georgia, and the West Florida coast. Rainfall has been above normal across the Florida Panhandle and Peninsula over the last 30 days or more. We have been drier and more scattered over inland Georgia and Alabama, as you would expect this time of year. 90-day rainfall totals have generally been normal over Alabama and Georgia to above normal over the state of Florida. The 7-day forecast is for heavy rain across Tennessee and the Mississippi Valley, perhaps even the headwaters regions of the ACF. Lesser amounts and more climatologically normal rainfall for the remainder of the basin. We are now in a La Nina watch with a 55% chance of it developing by this fall. The NOAA seasonal hurricane forecast strongly favors above normal activity. The CPC seasonal forecast for the August through October favors a higher chances for warm temperatures and also above normal rainfall across the Southeast. And kind of the final point, the ACF is likely to remain mostly drought free, but at this time of year, we do have to watch for pockets of quickly developing or flash drought as fall approaches.
Thank you, David. And Tom Littlepage could not be with us today, so I will speak on his behalf with the state of Alabama input from the Alabama Office of Water Resources. So the current U.S. Drought Monitor has the pocket of DO that David has already mentioned in southeast Alabama. And currently that's only at about 5% of the land area of Alabama. The current drought declaration is from the mid-June meeting of the Drought Impact Monitoring Group that meets for making these decisions across the state. And we have 4 different regions that have areas in a drought advisory. Note that only a single region, the southernmost region 9, is the only region within its entirety within advisory. Regions 1, 2, and 3 of the northwest section of the state have select counties in the drought advisory as of June 17th, but this is soon to change. We always like to mention that there's a tool for reporting drought impacts, particularly those for ag and forestry, that the Office of Water Resources houses on their website. The hyperlink to that is at the bottom of the page. You can also simply search ADECA Office of Water Resources, and there will be a link within that page to get to this spot. But anyone can submit drought impacts, and this is a tool that they're hoping to use more and more in the future, and it has been something that's been useful this year, particularly for prescribed fire and wildfire updates. Just generally speaking, the Alabama drought status is, there's been widely scattered rainfall, much as David has already alluded to, with the normal weather pattern for this summer. There's been some influence, particularly earlier in the summer, by tropical weather systems. It had been very dry in Baldwin and Mobile, the 2 southernmost and coastal counties of Alabama. And that was largely alleviated by a tropical storm that dropped about 10 to 12 inches in a single day about 6 weeks ago. This pattern is expected to continue. Also, there's no reported drought or water availability issues within any municipalities, and the Office of Water Resources continues to monitor those conditions. With that said, the Alabama Drought Monitoring and Impact Group is actually meeting today, directly after this meeting at 1 p.m. If anyone would like to participate and you don't already have a meeting invitation, you can get in touch with me or Tom Littlepage, and we can send that meeting invitation to you. And now I'll turn it over to Paul Ankhorn for our stream flows and groundwater conditions. Are you ready, Paul?
Okay, could you hear me now?
Yes, I can hear you.
Okay. Apparently I wasn't unmuted, but yeah, so here we go. These are our network for our real-time Streamflow stations across the Southeast. So the map on the left is from our last webinar, which was about 4 weeks ago, and map on the right are current conditions as of this morning. So just an overview of the whole region. You'll see last time we saw some pretty significant flows in North Carolina. Much of North Carolina now has decreased back into the normal range, which are indicated by the green pixels, green symbols across the whole region there. More locally here in Georgia and the ACF, we see conditions have also sort of returned back to normal conditions. There are a few stations that are currently coded in the 10 to 24 percentile, which are the orange pixels along the Chattahoochee River there, and then a few stations are showing low to much below normal, but those are likely release patterns, regulation patterns. Worth pointing out, the Flint River, the headwaters are currently running in normal range, but further downstream we're seeing slight reduction in flow down there towards the end of the Flint River before it joins the ACF, and you'll see conditions there are currently ranking in the below normal. So a little bit of variation there on the Flint. Our next slide, that'll take us over to the, this is the below normal 7-day average stream flow. So this is indication of hydrologic drought. So not a lot of change there, some lessening of hydrologic or below normal conditions in Alabama. What we saw last in our last webinar with some dry areas in western Alabama. Those have now decreased back to normal range, but we do see in the lower ACF some subbasins there that are currently ranking in the below normal ranking, which is 10 to 24% when based on historic flows. So, but as a whole, pretty much we're still in normal conditions, hydrologically, drought speaking. Our next slide, we'll start looking at the 28-day average. So the black line there is an average of the previous 28-day mean flows for the various stations. And these are Lake Lanier inflows, Chattahoochee River Cornelia, and Chestatee River near Dahlonega. Both sites there are declining, but that's what we expect this time of year, that downward slope towards September. Both these stations currently ranking well into the normal range, which is 25th to 75th percentile of historic flows. So we look good as far as Lanier recharge. Next slide will take us down below Lanier. So this is Chattahoochee River at Atlanta and Whitesburg. And again, we're seeing the same pattern there. Flows are slowly decreasing, but they both remain well into the normal range, hovering around the 50th percentile. All right, the next slide, we'll move further downstream. So this will take us down to West Point and Columbus, and pretty much the same picture here too. Both declining in slope, but well into the normal range. All right, next slide, we'll jump over to the Flint River. So starting at our most upstream site, Flint River near Griffin, and then moving to Carsonville. Again, flows are just well within the normal range. Next slide, further downstream. So we're looking here at Flint River at Albany, Flint River at Bainbridge. Again, they're a little bit of leveling out here, but flows are well within the normal range here also. So the last slide will be Chattahoochee River, I'm sorry, Apalachicola River at Chattahoochee, and we're seeing conditions there to be well within the normal range also. So the basin's looking good as a whole. Flows are pretty much averaging out to be well within the normal range. All right, our next slide, we'll look at groundwater conditions. So this is the groundwater, the real-time groundwater network in Georgia. So a little bit of change from our last webinar, particularly in the north or upstream area of the basin. Last time we saw normal groundwater elevations. Right now we're seeing they have declined slightly to below normal. And then a whole range, the whole gambit from low to above normal. But majority of our wells in the ACF are currently ranking in normal. So we look at two stations there that are circled. There are reference sites, Miller County being the first, and the typical fluctuation and slight decline that we expect for this time of year, but currently that ranks as normal. And then Doherty County is our next slide. And so conditions there just crossed over into above normal. We typically see fluctuations, likely irrigation, I would assume. So you see some drops during the month of July, but rebounded right back into the above normal ranking. So groundwater conditions look pretty good for the basin also. So we'll just wrap up with just our summary here. So real-time stream flow for the ACF basin currently ranked from normal to the low range. Lower portions of the ACF basin currently ranked as below normal for the 7-day average stream flow, but that can easily be lifted with a good rain event in that area. The 28-day average stream flow for the Chattahoochee and the Flint River both currently rank well within normal range, and real-time groundwater levels across the ACF basin are also showing much above normal to a few stations reporting as low. However, majority of the stations well within the normal range also. So that concludes it. Thank you, Rachel.
Thank you, Paul. Now I'd like to turn it over to Troy Ephraim to give us our ACF reservoir conditions. Are you ready, Troy?
Yeah, can you hear me, Rachel?
Yes, I can.
Okay, perfect. So we'll start at Lake Lanier and Beaufort. We've been above guide curve over the past couple weeks, and we're projected to stay there. Our midnight pool elevation today was 1071.15, and our 10-day forecast is 1071.02. Next slide. We're looking at West Point, and same story. We're operating above guide curve. We're positioning ourselves pretty well ahead of the Watershed George drawdown start. And we saw the midnight pool elevation 635.36 last night, and our 10-day forecast 635.5. Okay, next slide. Watershed George, you can see that we got the pool drawing down to do our upstream face dam repairs starting on September 15th, and we're hoping to be at elevation 186 by then. Our midnight pool elevation today was 188.6, and our 10-day forecast 188.05. And we're trying to stick with about a half a foot or a quarter of a foot to a half a foot a week up to September 15th. Next slide. At Jim Woodruff and Lake Seminole, same thing. We're operating within our parameters and meeting our downstream flow requirements on the Apalachicola River. Our midnight pool elevation 76.72, and our 10-day forecast 76.82. Next slide. This is the ACF Basin composite conservation and flood storage, and it's going to start trending down just a bit because of the Watershed George drawdown, but we're projected to stay there in zone 1 over the next 5 weeks. And in summary, I think Paul pretty much captured it, but we are seeing our inflows are staying relatively normal. Lake Lanier and West Point are operating above guide curve, which is to position themselves to be able to support downstream flows with the Watershed George drawdown. Watershed George is in zone 1 currently, and we have officially, thanks to Mother Nature, begun our drawdown, which was supposed to take place on August 1st, but that's to do the upstream repairs on the dam. And we're expecting our projects to approach guide curve or remain above guide curve, especially at Beaufort and West Point. And the ACF storage conservation is in zone 1 and forecasted to stay there over the next few weeks.
Thank you for the update, Troy. And now I'd like to turn it over to Jeff Dober for our Streamflow forecast. Are you ready, Jeff?
Yes, I sure am. Can you hear me?
Sure can.
Okay, so as David, Paul, and Troy both said, normal. And that's going to be the trend here in August, and probably will continue. I'll show the next slide shortly here, but continue in the next 3 months. As Troy pointed out, Lake Lanier at normal summer pool, and then we've seen some of the stream flows draw down with some of the warmer weather, the 90-degree weather from where we were last month, around that normal, the below normal level. But with the scattered showers and thunderstorms and more or less normal summertime weather, we think we're going to continue in that normal range for the stream flow forecast for the 1 month. And now if we go to the 3 months, August, September, and October, you can see our ensemble streamflow prediction pie charts, all favoring probably the best chances at normal streamflows falling in the normal range. And this continues to show the overall trend of normal this summer. Now, there is one caveat to that. As David pointed out, the CPC forecast has above normal chances for rainfall. And I think this is sort of highly pressed on the fact that we're anticipating the continued active tropical season. And so if we do get a tropical system make its way up through Georgia sometime during this period, then that would shift this, of course, shift the stream flows and shift the stream flow forecast to more of a normal to above normal levels. And so right now, normal is the most favored forecast. As you can see, probably above normal is the second most favored, and then below normal has the least number of chances, about more or less a 1 in 5 chance at below normal. Again, probably a 40 to 50, 50-50 chance almost on normal is how I would best describe it. So normal in the 1 month, normal in the next 3 months is the way we're looking at it. And actually that 3 month streamflow forecast should say near normal, not above normal. But near normal is what we're thinking the next 3 months. That'll go at least into early fall, early to mid fall.
All right, thank you, Jeff. Thank you very much. And now we'll have a special presentation about the Coastal Salinity Index. And shall I turn it over to Kirsten Lackstrom or Matt Pedowick first?
Yep, this is Kirsten. Can you hear me? I was going to start off.
I can hear you.
Okay, great. Kirsten, if I could just say one thing as a quick introduction. Sure. This current webinar series has been focused on the ACF region as part of the NIDIS Drought Early Warning System. Kirsten and Matt have, they're going to talk about something that was developed as part of a different drought early warning system. And I think she'll talk about it briefly, the Coastal Carolinas. She doesn't have to go through a background on that. The main thing is that we wanted to make sure we have an opportunity to showcase things that are being developed and built in one part of the country that could be really relevant to other parts of the country, and in particular, developing drought indexes for the coastal areas, including Apalachicola Bay. So I just want to thank you very much, Matt and Kirsten, for coming over to the ACF and sharing this wonderful work that you're doing. Thank you.
All right, thank you, Meredith. Yeah, and I want to thank you and Rachel for inviting us. And Meredith had also helped us distribute a CSI, so we'll refer to the Coastal Salinity Index as CSI, a survey to get feedback on the resource and some of the work we're doing to expand it. So you might have received that recently as well. So again, my name is Kirsten Lackstrom. I'm with the Carolinas Integrated Sciences and Assessments Program, funded through the NOAA RESA program. I'm located at University of South Carolina. I'll just briefly introduce our presentation and then hand it over to Matt Pedowick of the USGS South Atlantic Water Science Center. He's the lead on the CSI project. So the basic outline and purpose of the presentation, we wanted to just give an overview of the CSI in case for people who have not heard about it or aren't familiar about it. So why and how it was developed, what we're doing currently to expand the tool, and to show a couple of examples of some of the current research projects to assess how the CSI can be used for drought monitoring and other resource management decisions. The project has been supported by NIDIS as part of the Coastal Carolinas DEWS program, USGS, our NOAA RESA program, as well as other partners in the Carolinas and in Florida as well. So I guess the next slide would be great. Thank you. So again, the origins of this is with the Coastal Carolinas DEWS and the recognition that coastal areas are often affected by salinity intrusion and reduced availability and timing of fresh water to meet both ecological and human needs, such as water supply. And what we found with our engagement and research activities with different partners and stakeholders in the Carolinas is that salinity is a key stressor during drought, but we didn't really have a good way to capture that in terms of an objective drought index. We also found that there was limited use of existing drought information and tools by ecosystem or environmental natural resource managers. And we've also found that there's limited use of ecological and coastal specific information in drought monitoring. So you know, we were really interested in seeing if we could develop a unique index to help capture some of those impacts and conditions that occur during drought on the coastal region. So the next slide. And, you know, this particular image kind of shows, you know, what we're trying to capture here, right? It's really, you know, how are saltwater salinity conditions changing over time and during different types of events. And so if you're from the south or southeast, we know that, you know, we're not just interested in drought, we're also interested in wetter than normal periods. And so what we found with as we've developed the Coastal Salinity Index and continue to reach out to users and stakeholders is that, you know, there is potential to use it for monitoring wetter than normal conditions as well as drier than normal conditions. And so, you know, capturing some of the upstream conditions as well as downstream conditions, this index is helpful in helping us understand and monitor that dynamic. I think, so that was, you know, basically the general motivation, again, as part of the dues. Our target audiences, again, really are resource managers, those who want or need something to help monitor drought in natural resource management areas, or those who are, you know, managing refuges or research reserves, as well as the drought monitoring community, so that they have something where they can monitor drought in the coastal areas, and, you know, researchers who are looking at kind of that interface between those two fields and those two disciplines. I'm going to hand it over to Matt now, he can go into a little bit more of the detail about how it's been developed and what it actually shows and some of the resources and tools that we've developed as part of this project. So we can go to the next slide too, Rachel, I think.
Thank you. So the Coastal Salinity Index uses an approach similar to— Are
you on, Matt?
Can you hear me?
Yep, now we can.
I can hear you.
Sorry, maybe there was a delay. Yep, so the Coastal Salinity Index uses an approach similar to the standardized Precipitation Index, and it shows the probability of recording a given amount of salinity at a gauge. So here's our Coastal Salinity Index chart. It's showing the salinity classifications, descriptions, and threshold values. So what you do at a certain gauge is you take the monthly mean salinity data, you fit it to a gamma distribution and normalize it with a mean of 0 and a standard deviation of 1. Index values are the standard deviations from that normalized mean value. So an index value of 0 is going to indicate a historical mean salinity value. And that's that taupe color in the middle, normal salinity conditions. Negative and positive values are going to represent increasing saline and freshwater conditions, respectively. So you see that saline conditions are denoted as CDs. Those are coastal drought, and those are in yellows to reds. And they go from a threshold of 0 to -2. The blue colors are the positive numbers, and they represent coastal wet, CW, and they go from 0.5 to 2. And so these thresholds and the designations that we use for the Coastal Salinity Index, they were adopted from the standardized Precipitation Index. Next slide, please. And so the CSI can be used to compute multiple time intervals to characterize short and long-term droughts. And so here we have some CSI graphs that we'll discuss. Across the bottom, we have a 1-month Coastal Salinity Index graph. In the middle, it's a 12-month, and at the top is a 24-month Coastal Salinity Index graph. The y-axis is the salinity in parts per thousand, and across the bottom is time. And the black line across the bottom shows the 1-month average salinity value over time. The 12-month average salinity value is shown in black in the middle graph, and the 24-month average salinity value is shown up top in black. And so the colored background is the Coastal Salinity Index interval. And so as you look at it across the bottom, you see that the 1-month colors change every month almost. So it's a little bit more flashy for the 1-month intervals, and it's kind of smeared out over as you go from a 12-month to a 24-month interval. But for each of them, you can see that in the mid-2000s, about 2007, there was a drought that all three of the different intervals show up, albeit that the 24 months shows that it occurs a little bit later and is shifted a little bit to the right. These graphs that are shown here were developed from the East Bay Bottom Station in the Apalachicola NIRS network. Currently, we're using the CSI for 1 month intervals at a minimum. We don't get down to the daily or weekly intervals currently. Next slide, please. So the investigation that we just completed ended in 2019. We have these products and resources shown here. We developed a CSI-R package so that you can consistently calculate the coastal salinity index for any data set that you incorporate. That's located on GitHub. We have historic CSIs calculated along the Gulf of Mexico and Southeast Atlantic coast, and that's located in our USGS science-based catalog. We've got real-time CSIs located on 2 websites. One is our South Atlantic USGS website, where we have 17 stations located in North Carolina, South Carolina, and Georgia. We also have a real-time CSI website located for the Florida Everglades on the USGS Coastal Everglades Depth Estimation Network. In addition, last year we published this USGS report to document the activity that we did with the Coastal Salinity Index, and included also is a user's guide, a user's manual for people who use it. Next slide. So this year, in May, we received funding from the USGS Community for Data Integration project, and this is a short-term project to help us bring the Coastal Salinity Index further. And what we've decided to do is 3 objectives here. First, we wanted to identify and integrate additional real-time salinity gauges into our South Atlantic Water Science Center website. We're going to use USGS gauges, National Park Service gauges, and National Estuarine Research Reserve stations for that. We'll have up to about 150 gauges on that website, and those will be real-time gauges. We also are going to enhance that website to accommodate these new CSIs by expanding the map, include dynamic interactive graphs showing the coastal salinity index and salinity, temperature, and stage data. Also allow user-friendly tabular export of the results. And for the raw data, we're going to always point back to the originating agency for that data. And finally, one other product is going to be, one of our colleagues is developing R scripts for ecological analyses, and he's using case study investigation to synthesize data across spatial and temporal scales. And we'll be writing a journal article for that. Okay, next slide, please. So we do a quick overview. We don't have a lot of time, but just a quick overview of what it's going to look like. So this is our current South Atlantic Water Science Center website, but it's been updated with the new gauges. So we went from 12 gauges, or 17 gauges in South Carolina, North Carolina, Georgia, and here we're going to have over 150 gauges. Currently, we're not showing the National Park Service gauges in South Florida. But what you see here is the squares are going to be the NIRS stations. These are real-time NIRS gauges that we're incorporating, about 30 of those. And then the circles are going to be the real-time USGS gauges. And you can look at the gauges and see the color, and that'll tell you what the current state of the coastal salinity index that each of these gauges are. So you can kind of look at it and see what the regional distribution is for gauges in your area of interest. Of course, on the right, we have the tables to show you what the intervals mean. You can choose a 12-month CSI interval or 1 month or 9 month. That's going to be user selected. Okay, and if you click on a gauge, it'll pop up the CSI graphs for that individual gauge. Next slide, please. So a couple of the other, I'll go through briefly the other web pages that'll be available on this website. First is the second one is the About CSI. This gives the background information about the coastal salinity index and why it was developed. So it's the motivation, methods, classification, description, It describes our stacked graphs and use cases. Next slide. So this is what the map's going to look like for our additional data page. This is showing just North Carolina, South Carolina, and Georgia currently. No gauges are shown right now because it's under development, but this will be expanded to that full screen map. And the colors of the gauges are going to represent the current values of the selected parameters. The parameters are salinity, water temperature, and gauge height or stage. And what you can do is these are user selected on the right, and you can choose different intervals: 7-day, 14-day, 1, 2, 3 months, user selected. And it also will show the average values for those intervals and also the change in values for those intervals. Next slide. Next, this is a resources page, which shows you where you can go to find information about the Coastal Salinity Index, links to the R package, where the real-time data is located, user guide, and the published data and meeting presentations. That's the resources. Next page, please. So after we develop this, we need to find out what else can we do? How can we get this Coastal Salinity Index out there? How can we get people to use it? So we want to encourage outside researchers to use the CSI. And so we need to develop some case studies and work with researchers. And we want to work with drought and ecological linkages. We need to establish CSI critical thresholds and decision points for different areas of interest. And evaluate the use of the Coastal Salinity Index for resource and drought management. So once again, we have this diagram down below showing, the inputs to freshwater flow to the estuaries. You have rain, drought, floods, stream flow regulation, water extraction. All of these could affect where your freshwater saltwater interface is. Then you have tides and winds and tropical storms, and all of these are going to have effects. And these effects could be societal, economic, and ecological. And these are where the case studies can come from. How does vegetation change with these floods or droughts? Fisheries, how's the abundance of crabs, oysters, and fish? How does it affect the drinking water intakes or industrial intakes? And also, how will it affect algal blooms and tourism in the coastal areas? So those are just some of our ideas for next steps and future plans. Next slide, we'll briefly go over what a couple of our colleagues are doing. This is on the left, we're showing Chris Sorinsky, who's in Louisiana. He's used the Coastal Salinity Index to evaluate shifts in plant communities in an intermediate marsh in Louisiana. So these are two pictures of two different habitats of marsh grass. In 1997, it was one type, and in 2002 it was a different type. And the change was associated with a drought that occurred in the year 2000. So Chris has done a little bit of background information on that. On the right, we're showing some work from Simeon Urich, who's working in the Suwannee River. And he's trying to evaluate spatial applications of the Coastal Salinity Index, where we have multiple stations. And by synthesizing the CSI across these different gauges, he's trying to evaluate basin-wide patterns of salinity events and summarize these as intensity, frequency, duration, or spatial extent of extreme events. And so what he's done here is he's plotted like the first bottom graph is a 6-month CSI with all those 10 gauges stacked on top of each other. And he's trying to evaluate if there's a pattern that he can see for the whole basin. He's working on that currently, and we'll be publishing that in the near future. Other researchers have used the Coastal Salinity Index to evaluate the changing abundance of oysters and crabs and fish. Next slide, please. And so we appreciate your time. Here's two web links if you're interested. The first one is our real-time Coastal Salinity Index for the South Atlantic Water Science Center. And you can probably just search for Coastal Salinity Index, South Atlantic Water Science Center, and find that one. The second one is our sign up for a website usability webinar, which we're going to have in September. This is for anybody who's interested in the Coastal Salinity Index and might have input that they might suggest for our website. We're going to have that in September. you can go to that link or email us, and we can provide that to you if you're interested. Thank you very much.
Thank you, Matt and Kirsten. That is a really interesting tool, and we'll be sure to share information about that September webinar in particular, where people, will that be a hands-on activity? Will it be functional at that point in time?
It'll be close to being wrapped up. So it's just whatever's hanging out there might be there, but we'll have it in a shape enough that we can show it to people and let them give us some information and desires of what they think would be helpful. Not a lot of time to implement those, but we definitely record them, and we're always modifying and moving to the next phase. So.
Right, very cool. Well, thank you again for joining us today. It's certainly a tool that has a lot of potential uses that are kind of just being scratched on the surface at this point, it seems. And I'd like to thank all of our other speakers today. We have everyone's name listed and also resources that may be of use to any of our attendees. At this time, I wanted to open up the floor for any questions or comments for any of our speakers. You can use the raise your hand function or the question box. You can also unmute yourself if you'd like to ask the question directly.
Yeah. Hey, Rachel, this is David Zierden again.
Yes.
Great information on the Coastal Salinity Index. Pertinent to that, the Florida FWC and Department of Agriculture voted to close Apalachicola Bay to any harvesting of wild oysters for 5 years because the fishery has never recovered from the 2012 drought. And while that sounds harsh, oyster production in the area has mostly transitioned to cultivated oysters in Panacea and Alligator Harbor, and cultivated oysters rather than relying on the wild oyster fishery. So maybe that'll help it recover. It's an ongoing question. Since, as you saw with some of the graphs from East Bay, salinity has not been too much of an issue after 2012, but yet the fishery never recovered. So kind of a monumental decision, but not as far reaching now that the production has really transitioned to more cultivated oysters.
Interesting news, David. That's definitely been the trend in the Gulf off of the Alabama coast as well, that move to high density cultivated oyster farming. Any other questions for any of our speakers? If we don't have anybody who has a question or comment, I want to mention our next webinar will be Tuesday, August 25th at the same time. A video recording of this webinar will be available within 24 to 48 hours on YouTube, and a link for that will go out in our post-briefing newsletters that we typically send. I want to thank everybody for being here today, and have a good one.
Thank you, Rachel.
Thank you.